Hello everyone, welcome to our lesson on corresponding angles. Before we look at the corresponding angles, let's just discuss about parallel lines. Remember we've done 3 lessons about the geometry of intersecting lines. We studied by adjacent angles on a straight line, and then followed by the complementary angles, and then we did vertically opposite angles, and then we say those angles are formed by intersecting lines. So in the next lessons we're going to look at what the geometry of parallel lines. We're going to look at corresponding angles, alternate angles, and co-interior angles. So in this lesson we're concentrating on corresponding angles. Okay, so but if you check, we're going to use our knowledge about adjacent angles on a straight line, complementary angles, or even vertically opposite angles. Right, what are parallel lines? Right, parallel lines are lines which lie in the same plane and do not meet or intersect. So parallel lines do not intersect. They are at a constant distance away from each other, meaning that they are equidistant. Parallel lines are equidistant. And then a good example is the railway lines. The railway lines are at a constant distance from each other, hence they are parallel. So this is a good example of parallel lines. So you think of parallel lines, think of the railway lines. Okay, right. And then if the line AB and CD are parallel, they are drawn as follows. So we have line AB and line CD. How do we see that these two lines are parallel? We see them by this symbol here. We use the arrows to show that the two lines are parallel. So we use arrows. Okay, right. So that is that. And then we write AB is parallel to CD. We write AB is parallel to CD. Right. And then the line that cuts the parallel lines is called the transversal. The line that cuts parallel lines is called the transversal. So we have our transversal here, which is EF. So EF is a transversal. It cuts the parallel lines. Okay. How do you identify corresponding angles? How do you identify corresponding angles? How do you see that these angles are corresponding angles? Right, so we can see them. Let's just discuss a few ways. We can have different ways. I'm just suggesting here. So we can have this situation here. We're saying the corresponding angles are on the same side of parallel lines. You see that? So if you check here, this one is on top of AB, it's above AB. Even this angle here is above CD. This one is above CD. This one is above AB. So we can see that. Okay, even if it's below, it's fine. You can have an angle below line AB and the other one below line CD. You see that? Okay, right. And then also, or before we go to the next one, the other thing, they form an angle F. You see that? Then what about the orientation of the letter F? It can be oriented anyway, anyhow. Okay, right. So that is the letter F there, formed by the corresponding angles. Okay, and then also you can see that corresponding angles are on the same side of the transversal. Our transversal there is EF, so corresponding angles are on the same side of the transversal. Okay, like here we have the two angles which are corresponding being on the left hand side of what? Of EF. Okay, you can have a situation where our parallel lines are like this also. Okay, where this is A, B, C, D. Okay, and then this is our parallel line. Let's say E, F. See that? This is our transversal, not parallel line. Transversal. The parallel lines is A, B, and C, D. These are parallel lines. You see that? So the corresponding angles can be on the same side of what? Of the parallel lines. You see? This angle is on the left hand side of AB. It is also on the left, this angle here is on the left hand side of CD. And then both of them are above the transversal. Okay, even this one here, these two angles here are corresponding angles. You see, this angle is on the, or these angles must be equal because they are vertically opposite. Okay, or let me, it's easier to add another line here. These are equal because they are vertically opposite angles. So this angle is also equal to this. These are corresponding. They are below the transversal, both of them, and they are to the right hand side of the parallel lines. Do you see that? So they are on the same side of parallel lines and also same side of the transversal. Okay, right. That's how you can identify what corresponding angles. And then also you see it's forming the letter F there. Forming the letter F there. You see that? Okay. And then like which angle is corresponding to this one? It must be on the same side of the transversal and also same size of what, of the parallel lines. This angle is to the left, right of the transversal EF, and then it's below the line CD. So it must be to the left, to the right of EF, and also below line AB there. You see that? So that should be the angle there, which is corresponding to this angle. And then we have talked about this, that this angle is equal to this angle also because there are vertically opposite angles. Right, what can you say about this angle then and this angle? These two. What can you say about them? These are adjacent angles on a straight line. Adjacent angles on a straight line. They have a common vertex there and a common side. Okay, remember, said adjacent angles on a straight line, they have a common vertex and a common side. They form the letter Y. They form the letter Y there. And then vertically opposite angles, they have a common vertex, but they don't share, they don't have a common side. You see that? Okay, right. Now, corresponding angles are equal. Corresponding angles are equal. Just know that. And then the reason we write, we say corresponding angles, and then we write the names of the parallel lines. So in this case, we say corresponding angles since AB is parallel to CD. Okay, so like this angle is equal to this angle. Why are they equal? They are corresponding angles since AB is parallel to CD. Okay, and then the converse of that, what does it say? It says that if the corresponding angles are equal, then the lines are parallel. You see that? So let's say we're given this situation here. Let me name these angles E, oh, not the angle sides, E, F, G, H. Right, and then let's call it E, F, G, H, I, J. E, F, G, H, I, J, K, L. Right. Now, so let's say K1 and L1 are equal. We are not told that EF is parallel to GH here. We just know that K1, angle K1 is equal to angle L1. Okay. So if the corresponding angles are equal, then these lines EF and GH are what? Are parallel. So we can conclude here and say, therefore, EF is parallel to GH. And then the reason you write now, take note, the reasons are going to be different. We say the reason, we say corresponding angles equal. You see that? Here we just said corresponding angles, corresponding angles since AB is parallel to CD. Here we're saying corresponding angles equal. Let me say this again, the two things. Right, the first one, we are given parallel lines. So we're saying that, therefore, this angle is equal to this angle since they are corresponding angles and the line AB is parallel to line CD. Okay, then the converse. Now we are saying this line EF is parallel to line GH since the corresponding angles are equal. So if the lines are parallel, then the corresponding angles are equal. If the corresponding angles are equal, then the lines are parallel. Okay, so to understand that, understand the difference there. Right, now let's just discuss this right here. What can you say about these angles? We can see we have angle. Let's start with angle E2. Oh, this is not E2. Let me call this one G and then H. Right, let's start with angle G2. G2 is equal to which angle? G2 will be equal to which angle? Okay, you can see two angles that are equal to G2 here. Why is G2 equal to H2? We're not going to write anything, just fill in this right. Right, why is G2 equal to H2? They are corresponding angles if you check, okay? They are corresponding angles. And then why is G2 equal to G4? Equal to G4? Because they are vertically opposite angles. Vertically opposite angles. Right, even H4 here is going to be equal to H2 because they are vertically opposite angles. Any other angle that is equal to G2? We've done all of them, okay? Now, what can you say about G1? G1. G1 and G2 are adjacent angles on a straight line. Adjacent angles on a straight line, isn't it? So they are supplementary. They add up to 180 degrees. If you check, they have a common vertex and a common arm. They are adjacent angles on a straight line, right? And then, so it means G3 also is going to be equal to G1 then, since they are vertically opposite angles. Right, what can you say about H1? Is equal to what? H1 is equal to G1. What's the reason? The corresponding angles, since AB is parallel to CD. And then we come to H3 and H1. They are equal because these are vertically opposite angles. They're sharing a common vertex, but they don't share a common arm there or a common side. Okay, so these are vertically opposite angles. You see that? Okay, now let's try to apply what we've discussed as we do these questions. Given that AB and CD are parallel lines that are cut by the transversal EF and G2, angle G2 is 37 degrees, determine the size of H2. Remember, you can pause the video and be ahead of me, okay? And then after that, you can what? You can mark your work. All right, so now, which angle? H2? H2 is here. What can you say about H2 and G2? These are corresponding angles. See that? They are forming the letter F. They are on the same side of the transversal, and both of them are on the right hand side of the parallel lines. Okay, so now we can say angle G2 is equal to angle H2 since they are corresponding, they are corresponding angles, and then AB is parallel to CD. Okay, right, so it means therefore H2, angle H2 is going to be 37 degrees. Okay, this angle is 37 degrees. Okay, and then we move on to the next one. We want angle H1. We say this one is 37 degrees. So what will be angle H1? Again, you can pause the video and try to be ahead of me. Okay, so H1 and H2 are actually adjacent angles on a straight line. See that? They're forming common vertex, common side. Okay, they're forming letter Y there. So you can say angle H1 plus angle H2 is equal to 180 degrees adjacent angles on a straight line. Okay, adjacent angles on a straight line. And then, so angle H1 plus 37 degrees is equal to 180 degrees. So we can subtract 37 degrees from both sides of the equation But transposing is faster. We just transpose positive 37 degrees to the right hand side, becomes negative 37 degrees. Okay, so it becomes H1 is equal to 180 degrees minus 37 degrees. And then angle H1 is equal to 143 degrees. So this is 143 degrees. Okay, right. Let's move on to the next one. What will be the size of angle G1? We said this is 37 degrees. And then this is 143 degrees. So what will be the size of angle G1? G1 and H1, they are on the what? On the same side of the transversal, forming letter F there. And then this is G1 there. You see that? Okay, right. And then, so it means these two angles are what? Corresponding angles. Okay, so we can say G1, angle G1 is equal to angle H1 since they are corresponding angles. And AB is parallel to CD. Right, and then H1 is 143 degrees, so therefore angle G1 is equal to 143 degrees. So this is 143 degrees. Done. Okay, let's do the last one. We're done. And then we said, let's just save our information. Every time you're doing Euclidean geometry, make sure you write the information on your writer. Right, and then 143 degrees. So now we're looking for G3. What can you say about G3? What is it? What's the size of angle G3? It is 143 degrees, isn't it? Because these two angles are what? Angle G1 is equal to angle G3. Why? Why are they equal? Because these are vertically opposite angles. Vertical opposite angles. Okay? Vertical opposite angles. And then therefore we can say, therefore G3, angle G3 is equal to 143 degrees. Okay? We're done. We're going to meet in the next lesson.